We take that glowing silver sphere in the night sky completely for granted. But what if, right now, it's simply vanished? This diagram shows the scale of the energy required to destroy our lunar neighbor. To overcome its gravitational binding energy, you would need 1.2 times 10 to the 29th joules, an amount that dwarfs the yield of 600 billion tsar bombas. Since we lack the energy to physically dismantle it, our thought experiment assumes the moon is either knocked out of orbit by a rogue planet or simply blips out of existence. Removing that massive gravitational body removes the primary counterweight that keeps our oceans and atmosphere in their current state of balance. This cross-section shows the oceanic bulge the moon's gravity pulls toward itself. When that pull vanishes, the displaced water snaps back toward Earth's surface. That collapse releases an immense volume of energy, forming fast-moving Kelvin waves. These pulses travel rapidly across the global ocean. When these waves hit the land, the water violently sloshes into narrow inlets and bays, creating sudden surges that overflow coastlines. These immediate surges will eventually subside, but they leave behind a world stripped of its primary orbital regulator. Without the moon's constant influence, the biological and mechanical systems we rely on begin to drift. The oceans would not become perfectly still. The sun's gravity still exerts a pull, but solar tides are significantly weaker. Global tides would immediately shrink by about 75%. Organisms in the intertidal zones, like crabs, mussels, and starfish, evolved to depend on the rhythmic cycle of high and low water. Without that movement to provide nutrients and oxygen, these species face a rapid mass die-off. Because almost 3/4 of the human population lives within 31 miles of the sea, this ecological collapse reaches us directly. Billions of people rely on these coastlines for their primary food supply. By removing the rhythmic breathing of the sea, the disappearance of the moon effectively dismantles the foundation of the marine food web. On land, the loss of moonlight disrupts the internal clocks of global fauna. Nocturnal predators that hunt by sight lose their advantage, while migrating birds lose a critical navigational marker in the dark. We can see the moon's biological influence in the Great Barrier Reef. These tiny pink eggs are released during a synchronized mass spawning event that relies on cues from the lunar cycle. Without those cues, the spawning stops. When navigational markers vanish and reproductive cycles fail, species across the planet begin to decline toward extinction. For billions of years, the moon has acted as a planetary brake. Its tidal friction drags against Earth's spin, slowly stretching our day from 10 hours at the planet's formation to the 24 hours we have today. It is a common misconception that losing the moon would cause the Earth to speed up its rotation. This diagram shows the exchange of angular momentum between the two bodies. With the moon gone, that exchange stops. Our day would not get shorter, it would remain 24 hours long, but it would stop lengthening. This loss of tidal energy also affects the atmosphere. Major tidal flows help circulate water through the oceans. Without them, the mechanism for moving heat around the planet is significantly hampered. While our clocks would remain steady, the loss of tidal friction removes a key driver of global heat distribution and weather patterns. The moon's most significant role is as a gravitational anchor. It provides the stability that keeps Earth's axial tilt at roughly 23.5 degrees. This 3D wireframe shows the consequence of removing that anchor. Models demonstrate that without the moon, Earth's axis begins a chaotic wobble over tens of thousands of years. The tilt could reach 0 degrees or swing violently up to 85 degrees over millions of years. At an 85-degree tilt, the poles point at the sun. We would see tropical forests in Antarctica, while thick glacial ice forms over the equator. The predictable seasonal rhythm that allowed human agriculture and civilization to evolve is a direct result of the moon's stabilizing presence. Human culture has long perceived the moon as a passive backdrop, a distant, silent witness to our history. In reality, its gravity is a mechanical architect, maintaining the stability of our atmosphere and the rhythms of the global food web. The moon is the invisible engine that maintains Earth's habitability, making our very existence possible.